Okay, today we're going to be finding the determinants and inverses of a matrix on the calculator. So if you look at this first example, notice that there's vertical bars around your matrix instead of the brackets. Anytime that it has vertical bars around a matrix, it's not absolute value, it's talking about determinants, okay? So make sure you remember that the symbol, the vertical line symbol around your matrix is determinant. So we're going to find the determinant. Before I want to use the calculator, I want to show you how the formula for finding the determinant of a 2x2. So the formula for a 2x2 would be AD minus BC. And then on your 2x2 matrix, your A is your top left element, B is your top right, and then you have C and D. So that's your 2x2 matrix. So that's how you would find your determinant. When you're finding the determinant, we're going to be using that when we're actually solving the system of equations. So that's the reason why we need to find how to find the determinant before we actually solve those systems. Okay, so we're going to, let's go ahead and find the determinant by hand of this first example. So if I were to do AD, so multiply 2 times 8, minus B times C, so -5 times a -4. That would be 16 minus, when you multiply those, that becomes a +20. So notice that would give you a -4. Okay, so when you're finding the determinant of a matrix, you're going to get a number for your answer. It's not going to be a matrix. So that's going to be -4. Now on this 3x3, this is different. It has a different formula. It's more complicated, so we're going to do the calculator on that one. And so we're going to plug that in like we did yesterday on the calculator. The matrix, you're going to do second, and then matrix, which is your x to the -1 power. And then you're going to go over to edit. You're going to plug in your matrix. So I'm going to edit. I'm going to go ahead and just plug it into A. You have to write your dimensions. So the dimensions, remember, are rows by columns. So that would be a 3x3. So type 3, enter, 3, enter. And then you're going to type in your elements, which are the numbers inside your matrix. So we have a 2, enter, 3, -1, -3, 0, -8, 1, -4, and 6. Okay, so make sure once you use the calculator, make sure you're checking your elements inside the calculator and make sure they match, since the calculator is doing the work for you. Okay, if you mess up on one number, it's going to be wrong. Okay, so once you've typed in your matrix, like that's what we did yesterday, into your calculator, you're always going to go back to your home screen. To get back to the home screen, you're doing second, quit, or mode. There's your home screen. To find the determinant of a matrix on the calculator, you're going to go back to that second matrix, so x to the -1. You're going to move over to math, and notice number 1, it says DET, which represents determinant. Okay. So I'm going to press enter on determinant. I'm finding the determinant of my matrix that I plugged in. I plugged it into A. So I'm going to recall A by doing second matrix. A is number 1. And then you should get a number, so -46. So do the same thing on number 1. We did it by hand, but if you'd used the calculator, you should have got -4. Okay? All right, again, finding the determinants. That's going to help us when we're actually solving this system of equations. Remember the 3 methods that we already talked about for substitution, elimination, and graphing. We're going to use matrices to actually solve those systems. And determinants and inverses will help us do that. Okay, so that's the reason why we're learning how to find those. Okay, so let's look at the back here. Now we're going to find the inverse on a calculator. So the inverse of a matrix. Before we talk about an inverse of a matrix, let's talk about the inverse of a number. So for an example, if I had 1/2 The inverse of that is whatever would cause it to be 1. Okay, so basically you would take the reciprocal, which would be 2 over 1. Okay, the reason why we want it to equal 1 is so that way it would cancel out. So if we had an equation, say we had 1/2 x equals, just say 4. If we wanted to solve that equation, we would need to multiply this by the reciprocal, which is the inverse of 1/2. So that way they would cancel and equal 1, and you would be left with the 1x. So working that out, those cancel out to 1, and we get x equals 8. Okay, so talking about real numbers, if you have 1/2, the inverse of that would be 2 over 1. When you multiply them, it equals 1. Okay? All right, so we're going to find the inverses, and then we're going to talk about those last couple of examples on the bottom. Okay, so finding the inverse in the calculator, you're going to type it in, just like we typed it in yesterday. Type in your matrix, and then we'll talk about how we need to find the inverse. Notice the symbol for inverse is a -1 exponent. Okay, so there's a -1 button on your calculator that we will be using. So the first step you need to do is you need to find or plug in this matrix. I'm going to edit. It's a 2 by 2. So -9, 5, 6, -3. Once I've typed it in, remember, anytime you're finding something on the calculator, you need to go back to your home screen. So second, quit. We're going to find the inverse. To do that, we're going to recall matrix A, because that's where I entered it in. And then the -1, x to the -1, which is the button that you use to go to matrix before you type second. So don't type second, just type in x to the -1. It should say matrix A, and then it should say to the -1 power on your calculator. Once you type that in, you're going to press enter. When you're finding the inverse, it should be a matrix for your answer. It should be the same dimensions. Okay. Notice here that we have a decimal. You can change your decimal to a fraction. Remember, you go to math, and then fraction is number 1. If you press enter, then it gives you your matrix in fraction form if you have any decimals. So the inverse of this matrix would be 1, 5/3, 2, and 3. Again, we will be using inverses when we're solving a system of equations, which we'll get to later on this unit. Okay, so we're going to skip over 4. It's very similar. You plug it in, find the inverse. We're going to look at number 5. So I'm going to type matrix. I'm going to edit. I'm just going to plug it into A. It's a 3 by 3. So -2, 5, 1, -3. Make sure you're checking your elements to make sure that you're entering them in correctly. 1, 3. Okay, so once we type it in, again, check it. Okay, so they all look good. I'm going to go back to my home screen. I'm going to recall A because that's where I entered it in. And then I'm doing to the -1 power because I'm finding the inverse. That's what that symbol means. You're finding the inverse when it's a -1 exponent. I get decimals again. So to get fractions instead, math, frac, and you have lots of fractions here. So -11 over 53. Now notice I'm not able to see all of them, so I'm going to go ahead and write down the ones that I can see, and then I'll show you how you can find the other ones. Use your right arrow key, and then it scrolls it over for you. So that's -23 over 159, -17 over 159. And then that third column is 8 over 159, -1 over 159. When you're finding the inverse, again, you should get a matrix. Okay, should be the same dimensions as the one that you entered in. So if you end up with a 2 by 2 and you plugged in a 3 by 3, then you probably chose the wrong matrix on your calculator. Okay, so now on this last part it says, are these matrices inverses of each other? Remember we talked about at the very top of this page that when you multiply inverses together, they should equal 1. So like right here, those equal 1. So when you multiply a number times its inverse, it equals 1. So we want that to be the same case whenever we have inverses of matrices. So on these examples, what you need to do, when it asks if they're inverses, you need to multiply the two matrices. Now, we said at the top, when you're multiplying the numbers, it equals 1. When you're talking about matrices, when you multiply them, instead of it equaling 1, it will equal an identity matrix. So what that looks like is if you have a 2 by 2 on your matrix, your diagonal from left to right will be 1s, and then the other elements will just be 0s. So that's what an identity matrix would look like. Okay? On a 3 by 3, same thing, except you have a 3 by 3, but from left to right, your diagonals will be 1s. Everything else, all your other elements, should be 0s. Okay, so those are your identity matrices on a 2 by 2 and a 3 by 3. That's what it equals 1, and we'll talk about when we're multiplying why that equals 1. Okay, so if you're given two matrices and it says are these inverses, you're going to multiply them and see if it equals the identity matrix. If it does, they are inverses of each other. So that's what I'm going to do. I'm going to type in. I'm going to go ahead and write down which ones I'm going to type them into so that way I remember. Edit matrix A. A is a 2 by 2. So 2, 3, 1, 1. Check your elements. Edit B. It's also a 2 by 2. And also remember that if you have a 2 by 2 and then you have a 3 by 2, you wouldn't be able to multiply those because when you multiply, remember the insides have to match. Okay? So 1, 2, -1, and 3. That's a 6. Okay, so go back to your home screen. We're going to multiply like we were doing yesterday. We're going to multiply them together. So I'm going to recall A, and I'm going to times it by B. It says show the answer, so make sure you're writing down the answer that you get whenever you multiply them together. So notice this matrix is not the same thing as the identity matrix, which means these are not inverses of each other because it doesn't equal 1, which is the identity matrix. Okay? So just write yes or no on these, but just also make sure that you write your answer that you get when you multiply them. Okay? All right, same thing on 7. We're going to be multiplying them. So second matrix, I'm going to edit. I'm going to plug this one into A, this one into B. Check your elements once you've entered them in. So okay, so second matrix, go to edit. We're going to edit B. So it's a 3 by 3. Checking them, 7, 6, -3, 2, 2, -1, -6, -3. Okay, so we checked them. Now we're going to go back to the home screen and we're going to multiply A times B because that's where I entered them in. So I'm going to recall A, or name A, times B. That is when you multiply multiply them, you get 1, 0, 0, 0, 1, 0, and 0, 0, 1. Notice that is the identity matrix of a 3 by 3. From left to right, your diagonals are ones, positive ones. Everything else are zeros. It has to look exactly like that if they are inverses. Okay, so this is right. Yes, here. So if you're given two matrices, multiply them. When you multiply them, if it gives you the identity matrix, we know that those two are inverses of each other. To check your answer, you could type this one in and find the inverse of that. It should give you this one, okay? Or type this one in, find the inverse of that. It should give you that one, okay?